Hello. I received a package. It's been a while. You know, I've watched the EEV blog channel many times, and in it he uses, you know, like a huge prototypical Australian knife. So I'm going to use something a little bigger than that. We do things bigger here. Fortunately, this is not very sharp. Okay, this came to me from a friend. He sent me a text. The gentleman's name is Brad Hansen. He writes for Amiga Future magazine, and he found this in England and had somebody ship it over to him. And he wants to write an article about it. However, the unit doesn't work. This is the power supply here. And here's a big hint. Here's a controller. The rarest of the rare. Look, it's a smaller size. It's like the broadsword had a child. So let's see what shape this thing is. Packed very well. I don't even think I've even seen one of these in person before. And this is, there we go. So apparently this was partially repaired. But it has our favorite symptom, a green screen. That's according to what they say now. This thing looks like it's in pretty good shape. A little mar there. It has, oh look at that. It has the plastic covering protection over the logo. Wow. This thing's supposed to pop up. Cool. Okay, I had to relocate it into my computer area because the only way I can display this, the only thing I have to display this is a video capture card, because it only has composite output by default unless you add an expansion to it, whether it's regular composite or S-video. Unfortunately, my capture card, this is very likely a PAL machine. It's coming from the UK, and my capture device does accept PAL signals as well as NTSC, If I had an NTSC TV, that wouldn't, I don't believe that would work. Anyway, so let's turn it on. Okay. So we're getting a blinking green light, and here we're getting a green screen. Difference with this is that we get those blinks, and 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10 blinks, and then the thing resets. And it just keeps cycling that way. So apparently the last work that was done on this was to replace the processor. And the person who did that seems to think that all it needs is memory and memory replacement, and it'll work. I've ordered a diagram ROM replacement, but unfortunately I depend on diagram excuse me, I depend on using a serial output. I mean, when a Amiga has a green screen, you're not going to get anything on the video output. You're only going to get something on the serial output. But guess what? The CD32 doesn't have a serial port on it, so that's next to useless for me. If I get the thing working, I will plug the diagram into it and just, you know, verify that other things work. The other part of this that's not working quite right is I'm fairly certain that this is supposed to open farther than this. It seems to be stuck, and I don't want to force it. So when I open this thing up, I'm going to check the memory chips and order some replacements. And then while I do that, I'll look into why this lid doesn't want to open. There it is. This is the front of the unit there. Somebody wrote no startup on here. I'm going to give you a better look. I think the depth of focus is a little bit shallow. Anyway, yeah, so these are the same chips that are contained in an Amiga 1200. And the ROM chip is, except the 1200 has a double ROM chip. This one only has a single. And that makes sense because when I ordered the diagram for this, it was a single chip. But I wonder if the chip is one chip that's a higher capacity, a 1 meg chip. Oh wait, here's a Motorola chip right here. 68EC020. So that's the processor chip. So that one was replaced. And these have got to be the RAM chips here. Apparently you can do a mod to this fairly easily by adding on RGB output, which would increase the quality of the signal immensely. So U16, U17, U18, and U19, those have to be the memory chips. Yeah, copyright 1993, Commodore Electronics Limited. Spellbound, Revision 3. That was the code name for the CD32. Let's check out why this door wasn't opening all the way. Here's the mechanism over here. And now it opens. What was the deal? Was it possible that, see, it goes that way. I don't think the ribbon cable could have been in the way or anything. Okay. You know what? Let's see. This went like this. Flip it around. Ah, see this? That corner. I bet this EMI shield was interfering with the opening of the door because it was loose, you know. Looks like there's another slot for a ROM chip. It's interesting. So we have an Amiga CD32 with a green screen and continuous resets. Looking up on the internet for green screen on the AGA machines, you don't find nearly as much information. In fact, I didn't find anything specific to the CD32 about green screens. But this thing boots, and it's getting to the point where it's trying to test the memory and it's failing. So, you know, the amount of information that's available on the CD32, there just aren't that many of them out there. And, you know, this came from a place that had a pile of them that sent my friend one. This really isn't any better. Even though I have a little bit of information, it's really no better than having no information at all. It's really no better than buying it off of eBay and somebody saying it's NFG, you know, no effing good, dead, green screen, whatever. Because, I mean, the capacitors here that are normally spun around the wrong way from the factory, looks like they're in the right position here. And, you know, some people put red marks to indicate that they replaced them. You know, but did they recap the whole board? You know, am I going to find, is there going to be possibly some way for me to find if the capacitors have been replaced? Should I go to replace the capacitors? Could that be causing a green screen? So, you know, you start on this thing just the way you would anything else. You're going to test the voltages on the processor, the memory controller, and the memory chips themselves, you know, and the ROM, I guess, on all the major chips. Just check voltage and make sure we have 5 volts, I think it is. You know, I have memory chips on the way, you know, because they haven't made these in a long time, and it just so happens somebody in Spain has a few. They're not the exact ones, but they seem to be the same spec and same type. I mean, if you even just try to Google the memory chips, you're going to find limited information about them, and you're going to find absolutely no ability to buy them. You'll have to buy equivalents from other manufacturers. I think I found some Motorola ones, and these are some other brand. They're Siemens, I think. My best bet is to, you know, there is one chip that you can actually pull out pretty easy, and it's the ROM. So the ROM chip is, you know, you can take this out and put another ROM in it. So I have a copy of Diagram for the CD32 coming. This is coming from Ireland. And that is going to allow us to diagnose this, right? Well, as it turns out, the CD32 does not have a serial port. This is a keyboard port, but it's called the aux port, technically. It is, you can plug a A4000 keyboards or a CD32 keyboard into this and it works. And you can also get an adapter to plug a PC keyboard into this, and that also works. So we have options there, and we'll probably make use of them later, but it also has a receive and ascend pin on the same 6-pin or 8-pin connector, 6-pin I think, that is actually a TTL serial connection, and the one on the edge connector here is also a TTL serial. There's a problem with that. That's actually not RS-232. It's digital serial, so RS-232 is analog. So, you know, it isn't a serial signal that you can actually hook up to another computer with hyperterminal or whatever, or PuTTY, and actually read the signal. So I think I'm going to start by just checking the other person's work. Apparently they replaced the processor. So that's going to be kind of tricky. I'm going to have to I'll go on the schematic and I'll test every one of the pins against its equivalent wherever it's going. There's going to be some that go to the memory, some that go to the oh, this is Akiko's the one. Akiko's the one that replaced a lot of different chips on the 1200, and is the main reason why this board is this much smaller than an A1200, because they combined everything onto this guy. Anyway, so he's going to have connections to here. He's going to have connections to the ROM and the RAM. And I mean, it's simple, you know, when you come to think about it, except the scale of what we're trying to do, you know. The processor has quite a few pins on it. Every single chip does. And then you have this chip that does many things, which is great for compactness, you know, form factor. Yeah, I have a schematic for the CD32, and I also have somebody did a block diagram, and I added some notes to it. Okay, so here we have the system block diagram. Here's Akiko, and it shows gate array, but you know, this particular chip does a lot more than just gate array, you know, and you know, there's just some missing explanations, especially in regards to what I plan to do. So I edited the file and just added some things like, for example, here's the composite out coming out of the encoder, the S video composite as well as the regular composite. And you know, here's the source of the RGB signal coming out of the digital analog converter, the video DAC. Also, it shows I updated serial to say TTL, and over here as well that this didn't even, it just said future expansion, but really what all it is the keyboard port plus a TTL serial transmit and receive. That's it. It's only a 6-pin connector. And then I wrote down that this, because I'm not familiar with AGA, so I have to remind myself what chip is doing what. So this is the video chip, obviously, and this is what's controlling. This is the Agnes of the AGA machines. They changed it, called it Alice, upgraded it, whatever. And so you know, this could be a source of the green screen, or it could be the chip memory itself. Anyway, so Akiko actually has the CDR controller. You know, it shows it right here. It does timers. That's kind of what here we see, at least the source anyway. I guess that's a crystal or a chip creating that signal. This does service the game ports. We can see, yeah, right here, coming out here. And the keyboard, it's coming out here, and then there's also the serial. So this has a serial controller in it, and also Akiko, and also Paula has a serial controller. That's as far as I can tell. I mean, I don't see any kind of joining of the serial signal, and the schematics are here. So as far as I can tell, this computer comes with 2 serial ports, one of them coming out of Akiko and the other one coming out of Paula. The Kiko goes out the keyboard port, and Paula's serial goes out the expansion port. But one thing that is unique about the green screen problem is the system, the CD32 spontaneously resets. It blinks the power light 10 times and then does a reset, and then blinks the power light 10 times and then does a reset. So apparently I was told that the processor was replaced, and I'm not really sure. Other than some weird stuff, possibly a burn on, get something to point with, on that label. You know, kind of looks like a burn or solder mask, flux or something. But I don't know if I'd even attempt to do this without removing this label. I mean, originality is one thing, but if the darn thing doesn't work, then start removing labels if you need to, for God's sakes. I mean, it ain't real original if it's broken, right? So, you know, this is the only evidence I see. Here, it really looks like it was, you know, done in a factory or whatever. One of those pick and place machines or whatever they were using back then. This, however, this is the Akiko chip, and there was a solder ball on one of these traces that I just knocked off, and look at this one here. I don't know if you can see that. Anyway, look at this. Look at that. So that's kind of all the way around, a few little places, and it really looks like this is the chip that was replaced. So I might focus my connections, or my testing of connections around this. Yeah, it just looks to me like this is soldering iron work, you know, where you drag the soldering iron across, and it just, the solder hits the traces and goes up the traces a little bit, or maybe when you clean it, you take some of the solder mask away and the solder will just flow onto it. Yeah. It looks to me like this is the one that was replaced. Okay, so I found solder balls underneath. I found a couple of solder balls underneath these pins, just hanging out there. I was able to push them out with this pin, and I didn't find two. I think I might have found one other around the other sides, but there was two. One of them was a good size. So there's no question that this chip has been replaced, and that the person who did it wasn't super careful, obviously, because you know, he left solder balls both around the motherboard. I found a few around here and underneath the pins. So how do you get them under the pins? I mean, you take the chip off with heat, you clean it, you clean everything, and that would be the place where, if you messed up the cleaning, because that would be the place where you would get solder balls. Because, well, I guess when you're dragging your soldering iron across, you might create solder balls. Would they flip around and get behind the pins? I don't know. I haven't seen that, but I don't have a whole lot of experience with these types of chips. Just a few. I'm a OCS, ECS Amiga guy, so this is my first AGA, and boy, what a what a worst case scenario. Because out of all the AGA machines, this is going to be the one that is going to be the hardest to work at, simply because of this chip here. So many things are combined in that chip. I may have found something. In fact, I know I found something. Alright, so I was testing the DRAM, you know, the chip memory, and here are the 4 chips, U16 through U19, and I found a pinout of them, a little easier to read than this. So I started testing VCC on all the chips. Then you've got the, I believe this is the bidirectional input-output, and this is just address input. This is the A's are the address inputs, and the DQs, which are indicated I/O on the Amiga schematic. You know, in to out, that makes sense. But here on the manufacturer calls it DQ. And then here are the address lines. So I started testing this. There's nothing on the data lines. There's 4 here and another 4 here, and there's nothing on them indicating, you know, that I don't know if that's unusual. I wouldn't think so, because the computer isn't starting up. It's not able to put anything into memory. So why would that be working? So it was normal. I felt that I wasn't really seeing anything other than some interference or whatever. The addressing is all working. The row address strobe is working. The write enable is working. This is another A. I don't know why they call it A9. There's an R, but it's just A9. So I tested all these, and then I came up this side and I did VSS is ground, VCC is plus 5 volts. So I tested all these. The other address lines fine, not connected. Pin 6 and pin 21 are not connected. 22 output enable, and then for some reason, because I was getting close to the end of the chip, I decided to start on this end and test down this way, and these are giving me the usual readings. And the very last pin I tried, pin 23, the very last pin, column address strobe is right here, and I have a signal here, a signal here, a signal here, and I have nothing here. I've got nothing on U16 there. So let's just hold on 1 second. 28, 27, 26, 25, 24, 23. Okay, that's U17, for example. And then we're going to move to pin 23 on U16. 28, 27, 26, 25, 24, 23. And we've got nothing. Nothing at all. So I went to the schematic and discovered that it goes over to a resistor, and then it goes to a Kiko, the chip that has been replaced. And testing continuity, I discovered that there wasn't continuity from the resistor to a Kiko. I'll show you on the schematic. So here we are back at the schematic, and we're zoomed in a little bit. Let me just click it out a couple times. Alright, so U16 is the one that has no signal, and that is right here, the column address strobe. So it goes down to that resistor that I showed you. That's 152C, and I tested from the RAM chip to 152C, and I had continuity, and then I tested the other side of 152, and it seemed I had a little more resistance, so you know, it's somewhat functional. I could test resistance on there pretty easily, obviously, with my ohm meter, but I decided to keep going and see if we have a continuity between that part of this resistor and a Kiko. And sure enough, after double, triple, quadruple checking, triple checking at least, this has no continuity. So I inspected the board, and I guess we can do that next. Hold on. R152C, which is right here. So we're good there, right? But when we go from here to the Akiko pin, which is in this vicinity, there is no continuity. So I go back to the resistor. Then what we do is we take, so we're taking this side of the resistor, this side of the resistor goes to the memory chip. This other side goes to Akiko. And I don't know if you can see that, but I guess I can zoom in a little more there. You know, there's a pad right next to it, so you know, you test that. You go here and here, you know, and then from there you just follow this trace, right? And it goes to a via that brings it over to the other side of the board. It's gonna be tricky to capture on camera. Let's see if we can do it. All right, so I put the point of a piece of tape on that via, and then we're gonna spin it around. and put a light behind it, a very bright light. Okay, so the tape is covering this area where these vias are slightly darker than these ones up here, and I'm going to use my finger as well to move it around. My finger's right at the tip of it. There's one to the left and two to the right. So actually that means it's this one right there. Yep, it's that one right there. Let me just mark that with a piece of tape. Okay, so we have a piece of tape pointing to the spot there. So now let's trace that out. Let's trace out that trace. Keeping in mind where Akiko is here, so it's down here. Akiko's right here. I can't see what I'm doing. Akiko's here. Under, you know, it's on the other side of the board from my finger here. So let's trace this guy out here. Right there. Okay. Get a piece of tape on there. Come on, baby. Okay. And we can use a Sharpie, you know, to say that it's right here. Just to make sure I don't... Oh, you can't see. Oh, yeah, you can, right there. Yeah. So that's our trace. Not the one right below it, but the one right in front of it. Not that it matters, but this one right here. Okay, so where's my tape? My tape, put my finger on it, turn her upside down, and we're underneath Akiko. We're underneath Akiko, so that means that the via comes through to the underside of Akiko and then moves, gets a signal over to here. So this chip was replaced, and I think that a trace was broken. So during the replacement of the chip from heat or whatever. I have some pretty good stuff for this. Magnet wire. So this is so thin, and it's green. It actually is colored green. It has insulation on it, but the insulation is painted on. That's how thin it is. So, you know, you can try to burn it off. I've had better luck with scraping it off. So I just take a hobby knife and scrape it off. Let me do that. You're gonna have to look twice before you see this bodge wire. You can't go wrong with magnet wire at all. Magnet wire, that literally is what it is. It's what manufacturers use or people use to create windings good. And this is solid wire, and oh, I love using solid wire because you can bend it and put it in its place. I'm actually going to sort of leave it like that. If this fixes the problem, I'm actually going to undo it from the resistor. I'll take it off the resistor side when I receive my diagram, so I can go ahead and see what kind of diagnosis I can, if I'm successful with diagram. I mean, I'm going to be very happy if this fixes the problem, obviously, but I still paid for diagram for the CD32, so I'd really like to get my money's worth and put something up. Can you say cross your fingers? Here's my video capture device, the only way I can hook up to it now. Alright, here we go, 1, 2, 3. So we just get a black screen, but as we turn it on now, we'll see that we are dim green and then bright green. So we're definitely getting farther in on the startup sequence. I don't know if the drive is supposed to spin up or anything, but there's absolutely nothing happening besides this going from dim to solid and then just staying there stable. So it's back to the drawing board. I'm just going to test, now that the board doesn't have a green screen anymore, it's a black screen instead. We're on one of the address lines, and this is what we're seeing now. So it's a way to clean that up. But basically what we had is we had 4 pulses, and now we've got a lot. So, you know, it's getting farther, and it's got a continuous addressing pulse. Actually, this is an address line, so it's responding to information from a Kiko through a logic chip, addressing the RAM chip, and it's a continuous thing instead of just a 4-pulse thing, because we're getting past that. I would assume we're getting past the boot up, start up part where we were getting the green screen. So that's the signal coming from the address lines after we did that baud wire. And so let's check that one pin that wasn't getting the it's the column address strobe, like a pulse. I call it a column address strobe, CAS. 28, 27, 26, 25, 24, 23. So, I mean, that signal on the other chips was also a single sort of a 4-pulse thing, and now it's continuous as well. Now this makes a lot of sense. This is going to be like a clock signal, I imagine, where you're going to have a continuous pulse. Yeah, but anyway, all the chips now, all the 4 RAM chips are now, at least they're behaving the same way. You know, I've hit a roadblock. I've fixed one problem, and there's another one. So there's a couple of assumptions, or there's a couple of scenarios that you could take from this. One is that the Akiko was bad, somebody replaced it, messed up a trace for that, and also messed up another trace. And if we find out what other traces might be, you know, basically test continuity from Akiko's pins to where their destinations are, and make sure that that goes all the way through. You know, that's one scenario that we could tackle. The other scenario is that it was never the Akiko chip. They replaced it. They messed up a trace. It turns out the problem is elsewhere. For right now, today, the only thing I can do is test the rest of the continuity from Akiko to the rest of the components on the board, or the rest of the destinations on the board, and alternately wait for the diagram to come in the mail and try to get that to work with my TTL to USB adapter. It might be, you know, one of the other custom chips. It could be the processor. I don't think so, because it's kind of it got to the point where it was doing the memory test. I got a green screen, so a lot of things are working. it's just one thing that's preventing this from not booting up all the way. And you know, I have the audio hooked up here to my video capture device, so I'm hearing stuff, and I'm not hearing it. If it was video, if there was a video problem, I believe we'd still get audio. There's some kind of splash presentation music and screen that comes up. Well, I went and I tested all the pins. There's 160 pins on this. I went and tested 160 pins, and some of them were quite difficult because I had to put the probe on the underside of the board while I had the other end of the probe up here. I went all the way around. Here's my bodge wire for the one that I fixed, and you can see that there is another bodge wire. I got all the way around pin 153. I mean, basically at the end. It's supposed to have a connection. It's there's data lines that go to the ROM and to the processor. It's like a parallel connection, and they're just labeled D on the schematic. So let's show that to you here. I'm not sure this is going to focus because I have the that's all right. So here is the pinout of a Kiko, and 153 is D11, and then you go over to the 020 processor and you look, and it's on pin 49. So pin 153 to pin 49. So 153 to pin 49. Focus! And there was no continuity there, and I just was like, really? So I like double, triple checked it. You know, I checked the pins adjacent to it. I checked two different sources of, I actually have a diagram of a 68020 processor, and confirmed that pin 49 was a data line, not like VCC or anything, before hooking it up. Plus I tested it. You know, I turned the board on and measured voltage on it, and it was like 0.3 volts, so that's fine. And over here as well, so I didn't have any danger of hooking these two together. So I found that, and we're going to check it out and see what happens. And of course, after doing that, you want to test your connection. You want to test continuity between those 2 points. And you also want to check, I mean, because these connections are so tiny, you want to check for continuity with adjacent pins to make sure that you didn't short something out yourself. So 60, 59, 58, 57, 56, 55, 54, 53. So 53 is right there. And then 49 is right here. Okay, we've got that. We're good there. We're going to check the pins adjacent. We're going to check 48 and 50. And then we're going to go back here, and then we're going to check these two pins adjacent here, just to make sure we don't have any kind of problem there. And if you're really scared, if you're really conscientious of it, you're going to go and grab VCC, and I'm going to grab a VCC. You can't see it off screen. I'm going to grab a VCC from one of the memory chips, because those are easy to remember. And I don't have a dead short there, so we're not introducing VCC into it or anything like that. Cross your fingers. Okay. Let's just show you the screen here. And 3, 2, 1, go. That's behaving differently. I did it. Who's the man? Who's the man? Who's the man? I've never even worked on an AGA machine before. And this has got to be, I mean, it's not going to be the easiest one to work on. And I did it. I'm really stoked. I'm stoked for the person that I did this for. I'm stoked for the video that will show people how to fix one. Yeah. Alright, so I'm not getting any audio. That's pretty cheesy. The 90s aren't old enough to be cool yet. So I turned down the input level of the technically the microphone that is the input of my capture device. Yeah, that sounds good. All right. Let's try some software. Well, let me button this thing back up and then we'll try some software. So the owner of this CD32 sent me something that I would definitely need. He sent me some software for this. What is this? Okay, this one includes Workbench. Alright, we'll give this a try. First of all, let's just see if me putting it together did anything to it. No. Listening for the drive. Okay. That's a good sign, the light coming on. The disc stopped. The disc is not moving. Alright, well this is probably a good time to cut this off. We'll proceed to diagnose what's wrong with the CD drive on a subsequent video, I think, because we've really fixed the major issue. The Amiga CD32